Welcome to Lesson 2-3, Positives, Negatives, and Exponents. Today we're going to talk about identifying exponents, bases, converting from standard form to exponential form, and from exponential form to standard form. We're going to determine the sign of a number in exponential form, and we're going to determine the solution to a negative exponent. Right, so in order to work with these things, we have to actually know the vocabulary and what they mean. So an exponent tells us how many times a number is multiplied when written in exponential form. So the exponent tells us how many times we should see that number in a multiplication problem. So in this case, 3 to the 4th power, so 4 is the exponent. 4 tells us that I should see 3 multiplied by itself 4 times. The base then is the number being multiplied when written in exponential form. So the base number is now the 3 because 3 is what's being multiplied. Power, when we talk about power, power is a number that can be expressed using an exponent. So 8 is a power of 2 because 2 times 2 times 2 equals 8. Okay, we've also talked about perfect squares. So perfect squares and powers, if a number is a perfect square, it's also a power. However, there are more powers than there are perfect squares because there's a lot of possibilities for exponents. So you have a lot of possibilities for powers. So it doesn't just have to be a perfect square, because here you have 2 cubed. So 8 is a power of 2 because 2 to the 3rd power gets you 8. So in this case, 8 is the power. So let's say you had 4 to the 3rd power. 4 to the 3rd power would be 4 times 4 times 4. So 4 times 4 times 4, which would give us 64. So 64 is a power of 4. Squared is when a base is taken to the 2nd power, so it's when your exponent is 2. And cubed is when a base is taken to the 3rd power, so when that exponent is 3. And remember, squared and cubed also have to do with our units of area and volume. So when you see squared, you know that you're talking about the area of something. And when you see cubed, you know you're talking about the volume because it tells you the number of dimensions. So we get cubed because of the fact that in order to do that, you have to make a cube. And then we talked about squared because we know that when you square a number, whatever you get on the inside makes a perfect square. All right, so just a quick review, writing numbers in exponential form. When they're in exponential form, you have to have a base raised to the power of an exponent. So my base is the number that I'm multiplying. So in this case, I'm multiplying 4, and my exponent, and actually I'm going to go ahead and make that a different color so you know what I'm talking about. And then my exponent tells me how many times I'm multiplying that number. So I have 1, 2, 3. So my exponent should be 3. Again, my base is 3 because that's what's being multiplied several times. And I have 1, 2, 3, 4, 5, 6 of them. So it's 3 to the 6th power. So now we're going to go backwards and we're going to go from exponential form to standard form, so the way that you would typically see it. So the base tells me that I'm multiplying 3, and the 4 tells me that I need 4 3s. So I have 1, 2, 3, 4, and I know that when it's an exponent, that means that I'm multiplying all of those together. Okay. I also want us to take a minute. We're going to actually solve these as well. Because a lot of times we see students that do 3 to the 4th power and say 12 because they just multiply the two numbers, and that is not how this works. So you take your time and you go piece by piece. So 3 times 3 is 9, and then you still have 2 3s left. 9 times 3 is 27, and then 27 times 3, so you get 51. So 3 to the 4th power equals 51. I'm sorry, that is incorrect, not 51. 3 times 7 is 21, carry the 2. 2 times 3 is 6, 7, 8, 81. Forgot to multiply by that 2. So here we have 5 that's being multiplied, and you need 3 5s. So 1, 2, 3, and then I multiply. Again, 5 times 5 is 25. Times 5 is 125, so that would be our solution. So 5 to the 3rd is equal to 125. So this is standard form, and this is the solution. All right, so now we're going to look at what happens when we have negative bases. This is where your rules of multiplying with integers come into play. So negative 3 squared. I know that the 2 tells me that I should have 2 3's. And in this case, they're negative 3's. So I have a negative 3 and a negative 3. And I'm going to multiply those together. Well, I know that a negative times a negative is always going to give me a positive. So 3 squared is going to give me a positive 9. So let's look at what happens when I have 3 negative 3's. So negative 3 times negative 3 times negative 3. These two negatives give me that positive 9, but then I'm taking that positive 9 times a negative 3, which is going to give me a negative 27. So let's see if we can find any patterns here. So now I have a negative 3 times a negative 3 times a negative 3 times a negative 3. And we said a negative negative gives me a positive. And we know the positive and the negative gives me a negative. But now these two negatives give me a positive. So based on this, I want you to take a guess as to whether your answer or your solution is going to be positive or negative. All right, so then let's take a look. Put a line here. So I have negative 3 times negative 3 times negative 3 times negative 3 times negative 3. 1, 2, 3, 4, 5. Positive 9. Negative 27. Positive 81. Times the negative 3. So I know my answer is going to be negative. 1 times 3 is 3. 24. So we have negative 243. So I want you to look at this and see if you see anything that would help you indicate whether or not your answer, your solution would be positive or negative. Is there anything that you noticed, any pattern that you noticed in terms of your number in exponential form and your solution? What you should have found is that any time that your exponent is odd, you're going to get a negative number. Okay, so if your base is negative, and I'll type this to make it a little easier to read. If the base is negative and the exponent is odd, the solution will be negative. So what you're looking at here is you need a negative and a positive to make a negative number. So when you have two negatives, those are going to cancel each other out and make a positive. But then if you throw in that third, fifth, seventh, if you throw in that extra negative, it's going to make your answer negative. So anytime that you have an odd amount of negatives, so these two cancel each other out, and then these two cancel each other out. But then you have this leftover one right here, so this ends up making it a negative answer. Because you have an odd exponent, you have an uneven number of negatives, so you have that one negative left over to make your answer negative. Okay, and then the other piece of this then is, and this is only if the base is negative. If the base is positive, then your answer is going to be positive. So if the base is negative and the exponent is even, the solution will be positive because you have enough negatives to cancel each other out and you don't have that extra negative at the end. Right. So you should be able to determine, without even doing all this math, whether or not the solution will be positive or negative. Right, the next thing we're going to look at is what happens when you have a negative exponent. A very common mistake is students just think that that automatically makes your solution negative, and that is not the case at all. Okay, so I want you to make sure that you understand that x to the negative a does not mean negative x to the a. They are not the same thing. All right, so here we have 2 to the third power, and we're going to start with what we know to help get us to what we're learning. So we know 2 to the third power means 2 times 2 times 2. And I know that that gives me 8. And I know that 2 to the second power means 2 times 2, which gives me 4. 2 to the first power means I only have 2, so it's 2. But now I'm getting to 2 to the 0 power. So this is where we have to take a look at the inverse operations. So I know that to go down, so to go from 8 to 4, I either divide by 2 or multiply by half. It's the same thing. So again, divide by 2 or multiply by half. So it would make sense then that to get to my next number, I would want to follow that same thought process. So here, what ends up happening, we're going to use the solution to work backwards to get to our exponential form. So we'll get the solution, look at the math, and then look at the exponential form. So I know that my next number, I would have to divide by 2 or multiply by half. And that's going to give me 1. So anything to the 0 power is 1. Okay, and then here is your math behind it. We're just going to leave this one blank. So here I know that I would have to divide by 2 or multiply by half. And when I do that, I get 1/2. So what ends up happening here is I end up taking my number and putting it on bottom and making it into a fraction. Before we get into this though, let's look at what our next set of solutions will be. So divide by 2 or multiply by half. And when I do that, I can go up here, so 1/2 divided by 2 turns into 1/2 times 1/2, which is what we ended up doing anyways, okay, because we also said that you could multiply by half, which is 1/4. And once again, you divide by 2 or multiply by half. So I take 1/4, and I'm just going to go ahead and skip to multiplying by half, and I know that that is 1/8. So here, I find that I have the same numbers. So my exponent is 3, and there's still an 8 in my answer, but now it's 1/8. My exponent is 2, and there's still a 4 in my answer, just like it is up here. Okay, so I'll go ahead and highlight those. So when my exponent is 3, I still get an 8 in my answer, but now it's just below. When my exponent is 2, I have a 4 in my answer, but now it's just below. And then when I have a 1, it's by itself. I get the 2, but now it's below. So let's look at how mathematically we get from here to here. Well, we know that it automatically turns into a fraction. So anything to a negative exponent is actually going to turn into 1 over your exponential form. So 1 over 2 to the first power. Once you turn it into that fraction, it turns into a positive exponent. So it becomes 1/2. The math behind it is how you go from solution to solution to solution. Because to go up, so this is going down. So to go up, you know that each time you're multiplying by 2. So take your solution and multiply it by 2 to get to the next solution. So let's see if that works. 1/8 times 2. So 1/8 times 2 is 2 over 8, which is 1/4. And then 1/4 times 2 over 1, it's 1, that's 2, it's 1/2. Okay, so here's the math behind it and why it works and how it works. And then here's how you just do it without having to multiply or divide. So you have 2 to the negative second power, which is going to be equal to 1 over 2 to the second power. So you keep that exponent the same, but now it turns into positive, and then you find the solution to it. Here you have 2 to the third power is equal to 1 over 2 to the third power, which is 1 over 8. So you'll notice your numbers end up staying the same as you go up and down. So I know that my next answer here would be 16, so I can guess that my next answer here should be 1 over 16. All right, and as a general rule, what you can write down is that x to the negative a is equal to 1 over x to the positive a. All right, so we're going to go ahead and try a couple here. So we have negative 3 to the third power, and I want to know what the sign will be. Well, since it's an odd exponent and it's negative, it's going to be a negative solution. Negative 9 to the fourth, it's even. I'm just going to put exponent. So it's an even exponent, so it's going to be a positive solution. Okay, so now with this, we know that this is going to turn into 1 over negative 4 to the third. The 4, the base still stays negative, but the exponent changes to positive. So because it still follows the same rules, so because it has an odd exponent, it's still going to be a negative solution. Again, it's a negative exponent, but it's a positive base. So it has to be a positive solution. Okay, the negative in the exponent does not determine the sign of the solution. That just means that it'll be a fraction. Okay, and then I want you to solve a couple of these. So I want you to solve the 4 to the negative 4 to the negative third. And we'll bring down that a little bit. Negative 6 to the fourth, negative 3 to the third, and 8 to the negative fifth. So to solve that, this would turn into 1 over negative 4 to the third. So what I can do is just do 4 times 4 times 4, which I know is going to be 64. And I know because it's an odd exponent, or an odd exponent, that my solution is going to be negative. So this is going to be 1 over negative 64. Here, it's even, so I know my answer should be positive. So I can ignore the sign then, and I can just multiply. 6 times 6 is 36. So 6 times 6 is 36. Carry the 3 is 21. Is 36. Carry the 3, 9. So we get 1,296. Negative 3 to the third power. So we know that since our exponent is odd and our base is negative, we should have a negative answer. So I can ignore the signs and just multiply. So I have 3 times 3 is 9, times 3 is 27, and I know it has to be negative. 8 to the negative fifth, since my base is not negative, I know that my answer is not going to be negative. My answer has to be positive, but it's going to be a fraction. So positive fraction. All right, so you have to turn it into a fraction, so it turns into 1 over 8 to the fifth. And we go ahead and we solve. So 8 times 8 times 8 times 8 times 8. 8 times 8 is 64. 4 times 8 is 32. Carry the 3. 6 times 8 is 48. 49, 50, 51. 8 times 2 is 16. Carry the 1. 1 times 8 is 8. Plus 1 is 9. 8 times 5 is 40. Times 8. 8 times 6 is 48. 9 times 8 is 72. Plus 4 is 76. Carry the 7. 0 times 8 is 0. Plus 7 is 7. And 4 times 8 is 32. So we get 1 over 32,768. All right, so I want you to go ahead and determine the signs of the following and solve them. Okay, so try to determine the sign before you solve them. So we are going to do 2 to the negative third, negative 5 to the negative second, negative 3 to the fourth, and 8 to the negative third, and then we will also do negative 6 to the negative 3. Okay, so you're going to determine the sign of the solution without solving, and then you're also going to solve the problems above. As always, if you have any questions, be sure to email me or write them down so we can go over them in class.